Okay, this is Tech Math 2, and we're in section 8-7 today. And the first problem we're going to solve is from chapter 12 of a physics test. So that's what we're going to do, because it ought to be fun. Fine. So we have 120 volts RMS at 1,000 hertz. Now, where are you going to get that from anyway? It's pretty silly. And we've got a 2 microfarad capacitor and a 100 ohm resistor, and we have that many amps flowing in the circuit, and we want to know the value of the inductor. All right. Now, does it say it's in parallel?
No.
Does it say it's in series?
No.
No, it doesn't. So we're going to have to make some assumptions, right? Should we assume parallel or series?
Parallel.
Okay, if we assume parallel, then we have something that looks like this, right? And the current total has to be bigger than the current in any one path, right? And the current through the resistor would be 120 divided by 100, which would be 1.2 amps, and we only have 0.68 amps. So our conclusion is the circuit's not in parallel. Okay, so the thought that the circuit's in parallel doesn't work, so we're not going to do that. So we have a circuit that has 100 ohms, 2.0 microfarads, and some inductor that I don't know. All right. Well, spare me what we don't know, right? That's the bottom line there. But we do know that the resistor is sitting here on the real axis at 100, and the capacitor is sitting down there with some value of x of c, and the inductor is sitting up here going that way, some value of x of l. Okay. So now the issue is, could this be done with no inductance at all? Do I need inductance? So that would be the next issue. Okay, so we would solve for impedance. Impedance is equal to 120 divided by 0.680 amps. All right, so our impedance total 120, if I could write 120, divided by 0.68. Okay, so I've got 176.5 ohms at an angle that I do not know. I don't know that angle. How inconvenient. All right, now, but what else do I know? I know x of c. 1 over 2 pi fc. 1 over 2 pi 1,000 2.0 microfarads. I do know that angle minus 90. So I got that guy down. All right, so 1 divided by 2 divided by pi divided by 1,000 divided by 2, double E minus 6. 79.6 ohms. 79.6 ohms. All right, so now the issue is, if I have 79.6 ohms and I have 100 ohms and I have no inductance at all, could I make it to 176? So I look at the square root of 100 squared plus 79.6 squared, and I see that that's 128 ohms. So that means that this guy can't be 0. This guy's got to be bigger than that 78 in order for it to be in that away. So I'm going to be this away. I can't be that away in my thing. Okay, so that's the case. All right, so now, what do we know about the impedance? Well, the impedance is going to be the square root of the resistor guy plus x of L minus x of C squared, right? So because it's a Pythagorean theorem thing. So I know the impedance, 176.5. I know R, 100 squared. I don't know x of L, but I do know x of C, 79.6 squared. And that's why we're doing the problem, because the problem with radicals in it, right? All right, so now I'm gonna square everything I see. 176.5 squared minus 100 squared is equal to x of L minus 79.6 squared. Okay, so now I'm going to find this number, I'm going to find that number. 176.5 squared minus 100 squared equals, and I'm going to take the square root of it. Take the square root of it, and I get 145 is equal to XL minus 79.6. So I'm taking the square root of both sides of that equation. All right, so now we're getting somewhere. X of L is 145 plus 79.6 and 225 ohms, which is also 2 pi f of L. And what we're looking for is L. So L, the inductance, 225 divided by 2 pi 1000 equals. Okay, so I got that. Okay, divided by 2 divided by pi divided by 1000. And I got 35.8 millihenries. Ta-da! Did I do anything wrong? Perfect, right? I go up to the top and it says 34.2, 22.8, 11.4, 17.9, and 45.8. Ooh, I got a 35.8. Interesting. All right, so what am I going to do? I'm going to write my response here, 35.8 millihenries, because I know that one of the directions for the test is from time to time I remove the correct response. And when I do, treat it as an essay question. Okay? So this particular problem, what are the chances of somebody making a mistake doing it? Yeah, you have 10 different steps you got to do. You could make a mistake someplace, right? If you randomly pick one of those answers, you get 1 out of 5 chances of getting it right, right? No, not if the right answer's been removed. Yes, Virginia. Anyway, this is a problem that's on the current calculus-based physics 2 test that my web students are taking. And one out of 60 of them has emailed me already telling me that because you have a certain entitlement mentality, right? You're entitled to the air you're breathing is all you're entitled to. But basically, the kids at the 4-year schools have this entitlement mentality that says the right answer has to be there for a multiple choice question. No, it doesn't. No one ever said that. You're not entitled to have the right answer, kid. You're entitled to get a B in this class or whatever. You're not entitled to have the right answer. But you notice how we had to use our tech math skills in order to solve the problem. We didn't have to do any trig or anything. It wasn't all that hard. But we had to Yeah, but my poor students, most of them are going to get it wrong because they're not going to be able to break the stigma. We are in section 8.7. Equations in quadratic form. Oh, right. Just what we need. Oh, yeah. Isn't that great? Okay, so we'll warm up on number 1. X to the 4th minus 11x squared plus 18 is 0. Now, if it were x squared, we would expect 2 solutions, right? Well, x to the 4th equation, there could be as many as 4 solutions. Now, some of them might be multiple solutions, but there could be 4. Okay, so first thing we're going to do is try to factor it. So if I have x to the x squared and x squared, and this is minus 9 minus 2, then I'd have plus 18, I'd have minus 11. So then I have x squared minus 9 could be 0. X squared could be 9. X could be plus or minus 3. I could have x squared minus 2 be 0. X squared could be 2. So x could be plus or minus 2. So I got, for a 4th order equation, I have 4 solutions. So I got minus 2, minus 3, minus 3, minus 2, 2, and 3. And that's how I would write it as a tech math student. As a regular math student, I'd probably write it plus or minus 2, plus or minus 3. Either of those would be perfectly okay for answers. But I recognize that I'm going to get 4 answers. If I don't, I'm going to think about what I did wrong. Is there another way to solve that problem?
How did you get those 4 answers?
Well,
What are the back way?
Yeah. So I factored it.
Right.
And then I said, this guy could be 0. If that guy were 0, then x would be plus or minus 3.
Oh, yeah.
And then I said, well, this guy could be 0. Well, if that guy is 0, then x would be plus or minus 2.
Right. Okay.
No, not okay. Totally, completely wrong. Somebody want to tell me I'm wrong? Please, somebody tell me I'm wrong.
You gotta refactor it.
Huh?
You gotta factor it 1.
No, this is a square root of 2.
Oh.
Yeah, it's a square root of 2. Of course it's a square root of 2. Plus or minus the square root of 2. Yeah. Is the issue, do we have to go back in and check our work? And the answer is no, we didn't change the equation ever. So we could, if you wanted to, we'll put a 3 in there. 3 to the 9th is 81, right? Minus 99 plus 18, is that 0? Yes, it is. So we checked one of the 4. We could check them all if we wanted to. The other thing we could do, we could do a substitution. We could say x to the 4th minus 11x squared plus 18 is 0. Plus 18 is 0. Way to go. Get rid of the whole thing. And then we could, well, why don't we just say, let y equal x squared. This is y squared minus 11y plus 18 is 0. And then we could factor that y minus 9, y minus 2. And then we could say, okay, y could be 9, y could be 2, that's fine. And then we'd have to do back into here to get the x's and say x is plus or minus the square root of 9, which is 3, and x is plus or minus the square root of 2. So I could have done it that way and got the same answer too. Okay? Look at number 3 next. X to the minus 4th minus 17x to the minus 2 plus 16 is equal to 0. Oh, well, that factors. X to the minus 2, x to the minus 2, minus 16, minus 1. Right. So that factored. And then I could say, well, that being the case, x to the minus 2 minus 16 could be 0. X to the minus 2 could be 16. Take the square root of both sides. X to the minus 1 could be plus or minus 4. So x could be plus or minus 1/4. And then I do the same on the other side. X to the minus 2 minus 1 is equal to 0. X to the minus 2 is equal to 1. I take the square root of both sides, and I get x to the minus 1 is equal to plus or minus 1. I get x is equal to plus or minus 1. And then I say, okay, I'm going to check my 1. I put a 1 in there, and 1 over 1 squared is 1, minus 1 is 0. I put a minus 1 in there, I get the same thing. So plus or minus 1 is going to give me a 0. Minus 1/4 gives me a 4. 4 squared gives me 16. Minus 4 squared gives me 16. I'm going to get a 0. So everything checks. Okay. So now I'm allowing myself to think outside the box and work on a problem using the methods that I have to solve something that I hadn't seen before. Number 6. X plus 2 to the minus 2 plus 8, x plus 1 to the minus 1 plus 15 is equal to 0. 15 is 5 times 3, right? So this can be factored. X plus 1 to the minus 1, x plus 1 to the minus 1 plus 3 plus 5 is 0. All right, well, that being the case, x plus 1 to the minus 1 plus 3 could be 0. And so 1 over x plus 1 could equal to minus 3. 1 could equal to minus 3x plus minus 3. The minus 3 goes on the other side of the equation. 4 is equal to minus 3x. X is equal to minus 4 over 3. Okay, if I put minus 4 over 3 over here, I'm going to get a minus 1/3. 1 over minus 1/3 would be 3. So that guy's going to check. So that's good. I look at the other side of the equation. I can have x plus 1 to the minus 1 plus 5 equal to 0. 1 over x plus 1 could equal minus 5. 1 would equal minus 5x minus 5. I could have 6 is equal to minus 5x. I could have x is equal to minus 6 over 5. I come back up and put minus 6 over 5 plus 1 gives me minus 1 over 5. To the minus 1 gives me minus 5. Minus 5 plus 5 is 0. That guy checks as well. So they both check. I wonder if I can do 6 in my calculator. Probably not. I'll try. There's a numerical solve key above the sign and inverse sign. So I'm gonna use that key and say parentheses x plus 1 close parentheses raised to the minus 2 plus 8 times parentheses x plus 1 close parentheses raised to the minus 1 plus 15 plus 15. Oh, I just got rid of everything. Shit. Okay, now I got to re-enter the whole thing. I'm doing it again. X plus 1 raised to the minus 2. Plus 8 times x plus 1 raised to the minus 1 equals 0. Boom. Oh, look at that. X is minus 3 over 4. And I have 4 over 3. Oh, wait a minute. Solve for x. I haven't solved for anything yet. It's thinking about it. It's thinking about it. Still thinking about it. Oh well, it's still thinking about it. Okay, so maybe the calculator won't do that one. All right, moving down to number 13. Number 13. X to the 2/3 plus 2x to the 1/3 minus 8 is 0. Okay, so can I factor that? Yeah, I can factor that. So I'll factor that. X to the 1/3, x to the 1/3 minus 4 plus 2 is 0. Okay, so that being the case, x to the 1/3 minus 4 can be 0. So x to the 1/3 can equal 4. So x is going to be the cube root of 4. All right, the cube root of 4. And on the other side, x to the 1/3 plus 2 is equal to 0. X to the 1/3 is equal to minus 2. X is going to be the cube root of minus 2. And because this is an odd guy, I can do that. I can take the cube root of a negative number, but I can't take the fourth root of a negative number so I can't do that if I'm even, but if I'm odd, I can do that. All right, so that would be my answers, and then we'd say, well, I don't believe that. How can that be number 13? So if I had the third root of 4 raised to the 2/3 plus 2, the third root of 4 raised to the 1/3 minus 8, that somehow is supposed to be 0. Okay. So what do I got? I got 2 squared to the 1/3 to the 2/3. Okay, so that looks like 2 to the 4/9 plus 2 times 2 squared. See, I'm going to have 2 squared to the 1/3 to the 1/3. So that'd be 2 to the 2/9 minus 8 is supposed to be 0. Yeah, that's what I think too. 2. Oh, maximum integration time has gone out on my computer, so it's not going to solve that problem. Thank you very much, $20 calculator. 2 raised to the 4/9 plus 2 raised to the 4/9 plus 2 times 2 raised to the 2/9 ninths minus 8. Boom. No, that ain't right. No, that ain't right. So, what did we do wrong?
Factoring.
Huh?
Factoring.
The factoring was wrong?
Yeah.
X to 1/3, 1/3. Oh yeah, right there. I got to be plus and I'm going to be minus. Okay, so this is a plus sign and this is the minus sign. Okay, so this is going to be minus 4. That's going to be minus 4. I don't see where that's going to help me any. And this is going to be a plus and a minus and a plus and a plus. I don't see where that helped any. Putting minus signs there, that's just going to make this guy minus and this guy minus and the whole thing minus, and that's pretty hose too. Well, I think the best thing to do is to start all over. What do you think? That'd be the best. Oh, that's wrong. Okay, so we'll rewrite the problem again and see what we're doing wrong. Number 13. Okay, we're going to solve number 13 next. X to the 2 over 3. X plus 2 x to the 1 over 3 minus 2 squared is equal to 0. 2 cubed is equal to 0. By inspection, we find that the answer is 2. Well, that doesn't work, does it? Okay, so we can't do that. I'm not going to be allowed to say that. All right, okay. All right, so I'm going to factor it again. Well, I haven't done this problem yet, so I'm not factoring it, but I'm factoring it for the first time. X to the 1/3, x to the 1/3. Okay, that's good. And then I have plus 4 minus 2. Okay. All right, now I'm cooking with gas. Everything's good now. X to the 1/3 plus 4 is equal to 0. X to the 1/3 is equal to minus 4. I'm going to cube each side of the equation. And I'm going to say x is equal to minus 64. All right. And then I'm going to come over here, and I'm going to say that x to the 1/3 minus 2 is 0. X to the 1/3 is equal to 2. I'm going to cube both sides of the equation, and I'm going to have x is equal to 8. All right, so I've got, so x can be 8, or x can be minus 64. Okay, well, this is an odd number problem. Anybody look in the back of the book? Do I have it right?
Yes, you do.
Can I go on?
Yes.
All right.
I forgot
So-
about the whole multiply by the cube.
Yeah, that was pretty silly the way I was doing it the first time. But no one stopped me. No one told me I was hosed. Okay, number 15 looks cool. Does 15? Yeah, 15. If we do 15 and then we do 20, we'll probably be out of time. All right, so we'll do 15. Let's see how much time we have left. 3x plus 1 to the 4/3. 4/3. Have I written down the problem right so far? Minus 2. 3x plus 1 to the 2/3. Not another minus 8. Minus 8 is 0. Okay, so I'm going to factor this. 3x plus 1 to the 2/3 minus 4. and I'm going to have 3x plus 1 to the 2/3 plus 2 is equal to 0. Alright, so that looks good. And we know what we did wrong last time, so we won't do it again. 3x plus 1 to the 2/3 is going to equal to 4. Okay, and I'm going to take that and I'm going to raise it to the 3/2 power. Okay, I'm going to raise it to the 3/2 power. So I got 3x plus 1 is equal to 8. I got 3x is equal to 7. I have x is equal to 7/3. Do I believe that? 7/3. Okay, so this is 8. I'm going to check that first. So if it's 7/3, then that's 8, which is 16. 7/3 is 8, which is 4 times 2, which is minus 8 minus another 8 is 0. So the first answer checks. Okay, so that's always good to know. All right, second answer. 3x plus 1 is equal to minus 2 to the 2/3. And we're going to go and raise this to the 3/2 power. I can't take the square root of a negative number, so I have no solution here. Okay. So because I'm squaring this guy, and it doesn't matter if I square him before or after I take the cube root, he's going to be positive. The 2 is going to be positive. There's no way this can ever be 0. Okay, so anybody look in the back of the book? No one did. Okay, no problem. We'll just assume I'm right. Okay, 6 more minutes. We'll do 19 first, and then we'll do 20 second, because we have 6 minutes. We're going to do both of them. 19. Square cube root. Is that a cube root? Cube root x minus 3 6 root of x plus 2 is 0. All right, so I'll factor that. The 6 root of x times the, with the 6 root of x there, I got minus 2 minus 1 is 0. Okay, so that looks good. So
So
these,
if we took, like, say, means just the third root of x, we can take it at x times the 1/3 minus 3 times x 1/6 plus 2. Can you rewrite it like that?
you could, yeah. That'd be the chicken way out, to say x to the 1/3 minus 3x to the 1/6 plus 2 is equal to 0. Yeah, you could rewrite it like that.
Is it 2?
Well, because I know it makes the problem easier, but you know, my job is not to make it easier, to make a pain in the butt, right? 6x, the 6 root of x is equal to 2. Okay, so I'm going to raise this to the 6th power, and I'm going to say x is equal to 2 to the 6. That's 64, right? Okay, and on the other side, I have the 6th root of x is equal to 1. So that sort of means x is 1. All right, so we'll come back up to the original equation. If x is 1, then I got 1 minus 3 plus 2 is 0. So that checks. If x is 64, the cube root of 64 is 4. Minus 3 times the 6th root of 64, which is 2, plus 2, which is 0, which also checks. Okay. Now we can do our last problem of the day. The 4th root of x plus 2, the square root of x, is equal to 3. Okay, so we're going to rewrite that 2, the square root of x, plus the 4th root of x, minus 3 is equal to 0. All right, and then we're going to factor it. 2, the square root of x, the square root of the 4th root. 4th root of x, the 4th root of x, and then would have
I think you're missing this.
what?
Combine.
What do you want me to do?
Two square root of x is,
What 2 square roots of
you
x?
got one square root of x and you got 4 square root of x.
No, it's the 4th root of x.
But they both aren't.
Right.
The 2 doesn't
What's
belong.
the square? What's the 4th root of x times the 4th root of x? The square root of x. So 2, the 4th root of x, times the 4th root of x is giving me this term.
Okay.
Yeah, that's why I'm doing it that way. That's why I rewrote the problem so that the 4th root of x was the middle term, because the square root of x is the bigger power of x than the 4th root of x.
Okay.
All right, so you got that? All right, now I got it. Now I need a 1 here. Okay, so if I put a plus 3 minus 1 is 0. Okay, so now I got 3 of them, I got minus 2 of them, I got the middle term, and now I got that guy. Okay, so 2, the 4th root of x plus 3 could be 0. Okay, so now I got 2, the 4th root of x is equal to minus 3. The 4th root of x is equal to minus 3 over 2. Well, the 4th root of x can't equal a minus number. Okay, so there's no solution here. No solution. The square root of x can't be a negative number. The 3rd root of x could be a negative number. That'd be okay. But the 4th root of x can't be a negative number, so there's no solution there. So now I'm going to look at the other side and say the 4th root of x could be 1, in which case x would be 1. Yeah, x could be 1. Okay, so I come back up here and check, can x be 1? 1 plus 2 is 3. Check. Ta-da! All right, all done.